we are asked to find the equation of the tangent line, the derivative gives us the slope, the equation of the slope. It doesn't give us the equation of the tangent line. So when you're doing the derivative, y prime is the equation of the slope. It's not the equation of the tangent line. It's the equation of the slope. So after you do the derivative, you're going to put your a value into that derivative, and that's going to tell you what the slope is. After you find the equation of the slope, so that's the first thing you do. The second thing you do is you're going to plug in your a value to find the slope. After you've plugged a in there, you still need to get the equation. So at some point, whether it's your third step or your first step, is you need to plug a back into the original function to find y. Now the reason you need the y is because you already have the x, and what you're trying to find is the equation of the slope, the equation of the tangent line. The equation of the tangent line, you start out with using this formula. Y is equal to m x minus x1 plus y1, where x1 and y1 are the values for a and then f of a. So once you find the equation of the tangent and you find the equation of the slope of the tangent line, then you can do that replacement, but you still need, actually let's write it this way. This is f prime evaluated at a, that's your slope. And then it's going to be x minus a, and then it's going to be plus f of a. So as you see, you've got to find f prime of a, and you also have to find f of a. And then you've got the equation of the tangent line at that point. I'll go back in a minute so you can see the problem. Just a minute. Make sure everyone's had the opportunity to write all that down. All right, so the first thing we need to do is we need to find f prime of x, which is for this y prime. So we need to find y prime. We need to find the derivative. I'm going to write this as 1/4 x to the third minus x, so that I see that the 1/4 is just a multiplier. And so y prime is equal to 1/4 multiplied by 3 multiplied by x squared minus 1. So I have found the equation of the slope of the tangent line. I haven't found the slope as a numeric value. To find the slope as a numeric value, I'm going to put in my f of a. So f prime of a, which in this case, I'm going to evaluate y prime when x is equal to 0. So this is equal to 1/4 multiplied by 3 multiplied by 0 minus 1. This gives me my slope of -1. I still need to find out what my y value is when I put in 0, because I still need to find f of a. And so I need to find f of a, which is, in other words, I'm going to take and evaluate y is equal to 0 cubed minus 4 over 4 minus 0, which is just 0. Now I have everything I need to find the equation of the tangent. Now remember, the equation of the tangent is equal to the f prime of a multiplied by x minus a plus f of a. So I have everything that I need now to find the equation of the tangent. This will then equal y. It's not the same y as before. This is an equation of the tangent, not the y as the function that we had. Is equal to, we know f prime of a is -1, x minus 0 plus 0. So in other words, y is equal to -x. How did that go? Yes?
So you plug in a back to the original function. Your f of a.
Yes, my f of a is my y value associated to that a that goes in. And I still need that ordered pair. I need to know where it is on the the curve. I need to know what the y and x is on the curve to figure out what the equation of the tangent is at that place.
So you're not plugging in the negative. How like
No, the -1 is just the slope of the tangent line. Now this one, factoring is your friend, that friend that you sneak out of the house with. Or you can do it the hard way, which is the quotient rule. But if you can factor, please factor. So f of x is equal to, I'm going to factor out first an x. And that allows me to cancel those x's out. The numerator, does that factor more? What does it factor into? Now what? Cancel those babies out. So what I really have for my function is x minus 4 with a hole in the graph at 0 and a hole in the graph at positive 2. So there's a hole at x equals 0, because that's what I canceled out, factored and canceled out, and then a hole at 2, because that's what I factored and canceled out. The reason I'm saying this is because I need to go back to A and ensure that A is not where the holes are. Because we know that we can do derivatives on its domain. 0 and 2 are not in its domain. Is A equal to one of the holes? Then we're good to go. So let's go ahead and do the derivative now. Now remember, f of x is really just x minus 4, which makes our life so much easier. What is the derivative of x minus 4? 1. So f prime of x is equal to just 1. This is a line. X minus 1 is just a line. Just a line. How do I find an equation of a tangent line to a line? You really don't. It is the exact same line as what you start out with. That's it. It's the exact same line as you start out with. So we can still go through the process, though. Let's go ahead and go through the process. Here's my m. M is 1. I need to find f of, what am I putting in? 1. F of 1 is 1 minus 4, which is negative 3. That is my y value. Following the same algorithm, y is equal to the slope 1, x minus 1 minus 3. It's what you started out with.
Is this like proof by induction stuff?
No, no proof by induction. No proof by induction. I wasn't doing anything tricky. I was just hoping that you'd all factor and love yourself. So if you don't love yourself, please become one with your factoring friend and start loving yourself. Your factoring friend will help you love yourself. Okay, D is not as straightforward. We're going to do the derivative first, y prime. Y prime, what do you all get for y prime? 21x squared. Is that the slope? That's the equation of the slope. I still need to find the slope. So my slope is going to be y prime evaluated at x equals 2, which is going to be 21 times 2 squared, which is 21 times 4, 84.
Yep.
What else do I need to find? I need to find f of the original, so f of 2. So that's going to be 7 times 2 cubed minus 6. So 7 times 8 minus 6, which is 52. Now the equation of my tangent line is y is equal to my m, x minus my a, plus my f of a. Finishing this off, I have got y is equal to 84x, and then I have 2 times 84, which is a negative, plus 52. So what is the final answer? 84 minus what?
It's not 52, it's 50.
It's 50?
Yeah.
Oh, I've been led astray. I feel so unloved by being led astray. It's 50? It's 50, yes?
Yeah. We're as equally as sketchy as you are.
We have a lot of sketchiness today. 50, 50. Okay. I have 84 times -2 plus 50. What do you all get?
Minus 218.
Okay. There's my final answer. How was that? Is that okay? Yes. I don't know. I'm just writing down what you all tell me. Sketchiness, people. 118.
There we go.
Magic of marker and eraser. How are we doing? All right. Now we're going to just do derivatives of higher order. So we just do derivatives of derivatives. It's not that bad. Don't give me the evils. It's not that bad. These are awesome. Actually, you know, I gave you nice polynomials. So which one of these two would you like me to do? B? So f prime of x, my first derivative, is going to be 3 times 6 x to the 5th plus 7 multiplied by 2 x, and that's it. So I'm just going to clean this up. This is going to be equal to 18x to the 5th plus 14x. That's my first derivative. My second derivative is just the derivative of that. So f double prime of x is going to be 18 multiplied by 5, x to the 4th plus 14. Somebody with a calculator, 18 times 5?
90.
90? So this is going to be 90x to the 4th plus 14. X triple prime of x is just the derivative of that. So it's going to be equal to 90 multiplied by 4, x to the 3rd. Notice that I don't have anything trailing because the derivative of a constant is 0. So this is 360 x to the 3rd. And I can continue until I get to 0. How was that? These are delicious.
I was going to call it a jerk, but
No, yeah. They're actually not too bad. Go ahead and do A, please. I want the first, second, and third derivatives of A, please. All right, so let's take a look at A. F prime of x. Who would like to give me f prime of x? Raise your hand if you'd like to give me f prime of x. Jacob.
3x squared minus 4x plus 3.
F double prime of x. Who would like to give me f double prime of x? Madison.
6x minus 4.
And the third derivative. Who would like to give me the third derivative? Vicky.
6x.
So-
6.
Okay. How was that? Not too bad. Okay. Please do C and D. And you know who's your friend on D? Factoring. She or he is still your friend. All right, e to the 2 is just a constant. So when I do my first derivative, f prime of x, who's going to give me f prime of x? It hasn't given me an answer yet. Yes.
70x to the 6th minus 1x.
Okay, who would like to give me the second derivative?
120x to the 5th times 1.
Who would like to give me the third derivative?
2100x to the 4th.
2100 x to the 4th. How was that?
I have a question. What happens to the e to the power of 2?
E to the power 2 is just a constant. It's approximately around 6. So on D, your factoring friend helped you out, and your factoring friend made this to be what?
W squared minus
W squared minus W.
We like that. So f prime, who would like to give me f prime who has not given me an answer yet? Dallas, who's not making any kind of eye contact with me. What is the first derivative?
W.
It'll be 2w because the power is going to come down out front, and then minus, not quite W, I'd bring the power down out front, so that's 1, and then I bring it's W to the 1 minus 1, which is W to the 0. So it's just going to be 1. Who would like to give me the second derivative on this? Bryson?
2.
Who would like to give me the third derivative on this? James? No! What's the derivative of constant?
0.
That'd be 0. You guys are rock stars. Okay, was there any questions on the higher order derivatives?
No, they're good.
We like higher order derivatives. Okay, so on these, you're going to see them on the test or on the homework, and you might see it on the test. Find the equation of the line passing through the point 3, 3 and tangent to this graph. What does that first 3 represent here? That's my A. What do you think the other 3 is? F of A. So what do I need to find? Just what? I just need to find the derivative. So go ahead and find F prime, please. And then over there on the board is the way that you can do the quotient rule. And unfortunately, our factor friend failed us because we have nothing to factor. So the derivative is just going to be negative 6 over x minus 1, the quantity squared. I have my A and F of A. What do I need? I need to find my derivative of my function evaluated when x is equal to 3. So I do need to do that. So this is going to be equal to negative 6 over 3 minus 1, the quantity squared. So it's going to be negative 6 over 4, which reduces to negative 3 over 2. How are we doing? So now I just need to find the equation of the tangent. So it's going to be y minus y is equal to my slope, which is negative 3 over 2, x minus my a plus my f of a, and then I just need to clean that up. Right? So before we do B, we're going to talk about C. When they're asking me for the tangent, where the tangent line is horizontal, what am I being asked for? When they ask for the tangent line to be horizontal, what am I being asked for? My slope to be 0. So how do I find the equation of the slope? Derivative. So just do the derivative. And when you do the derivative of this, what do you all get? Okay, that's the derivative. I need this to be 0. So I'm going to set it equal to 0. Which means, I'm going to see if I can factor this. Does this factor? Remember your factoring friend? You're going to sneak out of the house with him this weekend? What does this factor into? So what is the x equal to? Does anyone know what those represent? Those values represent? They're what? They are the locations of my extrema, my turning points, my min and my max. Those are the locations. Okay? Yes?
I do know that it's a turning point and not a hole.
So because it's a polynomial, it won't have a hole to begin with. Yeah, so the question was, how do I know it's a turning point and not a hole? And that's because it's a polynomial, so it has no restrictions on the domain, so there's no holes in it. So how do you think I'm going to do the second part? Find the tangent of the line that has a slope of -1. I'm going to set it equal to -1. So I'm going to do 3x squared plus 2x minus 1 is equal to -1. So now what? I look at you all, you look at me back, I wait, you wait, class is over. No, that's not how it works.
Oh, man. Really not.
Now what? Add 1. Then what? Factor out an x. So where are there two places in which the slope is a -1? When x is 0 and when x is -2/3. How was that? Okay, now the reason I did that first is because I want you to talk with your partner on B. How would you approach B? So talk with your partner, give you a couple of minutes to talk with your partner about how would you approach B. Let's talk about each piece here. F of 1 equals 5. What does that tell us? Does that tell us anything? Tell us what? Yeah, so that means this. All this is telling us right now is this is 1, 5 is on the graph. What does f prime of 1 equal 3 tell us? Gives me the slope of the tangent, but it also tells me that 1, 5 is not the vertex. Tells me it is not the vertex. So what about f double prime of 1 equals -6? What does that tell us? Well, it tells us all kinds of stuff. All of these combined tells us all kinds of stuff. Let's go over here and talk about a quadratic in general. Quadratics are ax squared plus bx plus c. Call this my function. What is my first derivative then? Okay. But I know what f of prime of 1 is. F of prime of 1 is equal to what? 3. That tells me that 2a times 1 plus b must equal 3. So I have 2a plus b is equal to 3. That's the first thing that I know. So let's do the second derivative. F double prime of x. Second derivative is going to be what? What is it? No, what is the derivative right here of this? What is the derivative of that? 2a. But f double prime of 1 equals -6, which means that 2a must equal -6. So what does a equal to? So can I find b now? So I can go back and I can find b, because I know what a is. So that means -6 plus b, that's a really bad, those look like two b's. -6 plus b is equal to 3. So what does b equal to? How do we find c? Well, we're going to have to go back to our very first one. So what I have so far is I have f of x is equal to -3 x squared plus 9x plus c. And I go back to my very first information, and I know that f of 1, which was equal to 5, so that's equal to 5, which is equal to -3x squared. Oh, I want to put a 5 in there. So 5 squared plus 9 times 5 plus c, and that's how you're going to find c.
Would you put in 1 instead of 5?
Oh, yes, sorry. I was just seeing if you all are awake. And clearly you are. We put 1s in here. Thank you.
What did you do?
So what is my c value?
-1.
So my final is f of x is equal to negative 3x squared plus 9x minus 1. And there's my final answer. How was that?
A lot easier than I thought it was.
It's all good. Now, if this was back up here, if this would have been f prime of x, f prime of 1 was equal to 0, what would that have told you then?
Some straight line.
So if this would have equaled 0 right here, if this would have equaled 0, my derivative equals 0 when I put in 1, that means I'm at a turning point. So for a quadratic, what does that mean for my turning point? What do we call that turning point for a quadratic? A vertex. So if they would have gave that equal to 0, then I know that I was at then 1 comma 5 is the vertex. Does that make sense? Okay. All right, we still have 5 minutes, so we're done with this. We are going to enter into the new one. It'll be the best ever.